What do you see the key factors of such success in China?
Well, you have to see that TSP is basically a geophysical tool. I mean, it uses a geophysical principle of sound propagating into the rock, and the backcoming echoes are analyzed, and then information about geological changes or hydrogeological phenomena are extracted out of the geophysical data. But the result as such are pure geophysical data. I think the success of TSP in China is the fact that in China, or the Chinese applicators did not stop there. They tried, and they are successful in linking these geophysical data to constructional aspects. TSP did not remain a geophysical instrument which has no access to the ongoing construction work. It was used as an input which has an impact on how things are done on the job site. So therefore it has become a normal tool to be used because it created very valuable information on the civil works. And I think the high acceptance and the large use of TSP in China has to do with this Chinese way of further develop, or the application of the results of TSP. So, you know, for instance, that every year we have TSP user meetings where in such information and how to use best TSP in tunnel excavation. So there has been an ongoing culture of how to improve the quality and of the results and for civil engineering.
So this kind of experience is also very useful in other parts of the world.
Sure, absolutely. Measurements, that also goes for deformation measurements, whatever type of measurement. The key element is how to bring these measured data into constructional aspects. And in this sense, artificial intelligence or IoT could be of high interest, and a lot of research is going on there. The TBM is a huge exploration tool, which means the thrust, the power, the rotation speed, all this is an indication of the geological condition. So if you are capable to use that data in combination with geophysics or other information, then you can increase the quality in civil works, saying under these conditions, the rock support should be that, or the lining should be that, or the bolting should be that. So in this respect, artificial intelligence can contribute to an enhancement of the evaluation of measured data, being them TSP data or other data. And I think explicitly in China, with the knowledge in KI and artificial intelligence, that could be a very interesting topic to further work on that.
As I know you are already stay in China for several days, so what is your perspective about our future cooperation between Switzerland and the Chinese internally industry?
There are differences. Switzerland is small and China is large. In China, you have a much larger volume in the future of construction of tunnel underground infrastructure as such. But when we give a little bit a closer look, China and Switzerland have some similarities. You also have mountainous regions, so where you need classical mountain tunneling, but you also have, let's say, a lowland, flat land, where you have maybe a soft soil, etc. And we also have in a certain area in Switzerland where we do a lot of soft soil tunneling. There is, let's say, similar problems, although the magnitude is different. But coming from that viewpoint, I think there are a lot of similar technical challenges in Switzerland and here in China, which will allow to have an interaction, which will allow to exchange knowledge gained either in China to be used in Switzerland or vice versa. What you also have here in China, but that's a global trend, is a growing urban population. Cities get larger and larger. Cities normally are not somewhere in the mountains, with a few exceptions. Normally they are in the lowland, near the coast, near rivers, technology on how to build tunnels under these specific conditions, underneath lakes, crossing rivers, etc. So I think from a technical viewpoint, although the countries are different in size, we face similar problems. So there will be certainly a base for the exchange between knowledge gained in Switzerland for China and vice versa. Huh?
So, Felix, I want to ask you the last question. What do you see the future of the tunneling?
Tunneling has a bright future. It will, as I just mentioned, the urbanization. And when you live in a city, then you know the traffic problems every morning. You have a lot of people. Mobility is an issue, etc., etc. People need to go back to commute, etc., etc. Urbanization certainly will be one of the few responses to that is to build infrastructure underground, under whatever type of geological and hydrological condition. So this urbanization is a motor to drive underground industry, to drive tunneling. If you think of other challenges than just number of people, if you explicitly think of climate change and what goes together with climate change, there might be less rainfall, but more intensive rainfall. So how to get rid of that water out of cities? On the other side, we face in summer higher temperatures. So how can you collect that water to use it for cooling in summer, in hot summers? You should not let the rainfall go to the sea. You should keep it in order that you can make use of it. Where can you do that? Underground. If you want to store large quantities of water, you only can do that underground.
But do you think the artificial intelligence will replace the engineers like you and me in future?
Tunneling was different to the way we do it now. There's a lot of, geotechnical modeling, all these finite element methods. They were at the beginning. My father, maybe your father when he was a miner, they were practical engineers. They had a lot of experience, but very limited theoretical know-how. And we learned a lot of theoretical know-how through all these numerical methods, etc., etc. So we already had a change which we have to. And now there is artificial intelligence coming. There are new digitalization, BIM, all these kind of things are coming. But it's just new tools. So there, of course, it will change the way tunneling is be done because you have other tools. But the challenges will remain the same. The demand for tunnels will even increase. So I'm absolutely positive young people who decide to study underground infrastructure construction, design, they will have a bright future. Although it will be different to what you and I have learned and how we do it, they will do it differently, but it will be a large field where engineering knowledge.
I know your understanding is that artificial intelligence will not replace the tunnel engineers, but will provide another tool for tunnelers.
I even would be a little bit provocative. How does artificial intelligence work? Artificial intelligence works in the manner that computers, very simple, use existing knowledge. They use what is best practice, so to say. What is in the codes, how to do certain things. That is how artificial intelligence works. The computer, so to say, absorbs the state of the art. When I say the challenges of the future in underground construction is in how to use the underground space. There are total new things. Underground farming, for instance, the storage of rainfall, the energy storage. There are new types of challenges where little experience is available. So the computer, the artificial intelligence has limited possibilities to say how this works. But the ingenious type of work is with the use of the underground space where we have little knowledge. There engineers are necessary to say what are creative ideas, how to make use of underground space. So if the computer just tells me how to do another metro line, then I say, of course it's engineering, but that's not the challenge as an engineer, because we have a lot of knowledge there. But on how to make a smart city resilient against the climate change, no computer can give me an answer. Engineer knowledge is asked, creativity is asked. So I think for young engineers to have this challenge, how will the world be in 20 years, in 30 years, under these challenging conditions? What is the contribution of underground space? How can underground engineers contribute to resilient smart cities? That is a challenge no artificial intelligence can give an answer. So from that viewpoint, I'm absolutely not afraid that computer will replace engineers and explicitly in our domain.
Felix, your idea is very interesting and it's very enlightening in my understanding. It has been an absolute honor to have Felix with us. His vision and achievements are an inspiration to tunnel professionals worldwide. So thank you for joining us on this journey into the depths of tunnel engineering. Goodbye and see you at the next episode of Bayin's Tunnel Talk.